So here's the next two chapters. So if I were to break down what we've done so far and doing in the future, that's called inferential statistics. Remember, we're like estimating to a population. We've already done sampling distributions. There's 3 parts. We've done sampling distributions. This unit, we're going to do something that we call confidence intervals. And then the next unit, which is when we get back from Christmas break, we'll do something called hypothesis testing. So that would be unit 8. And then we'll actually only have, after this, we'll only have one more unit, and then that will be everything. And we'll spend the rest of the time reviewing before the final in the spring. So we're learning a big chunk of it right now, and then right when we get back from break, and then we'll have a lot of time to kind of go through that and expand. And so what inferential statistics is, just to kind of go back and talk about, it's when you don't have population data, all we have is sample data, but we're trying to make projections about the population. So if we didn't have access to everyone in the world, but we wanted to make a statement about that, like find an average or find like what is the average amount of time people watch TV, but we couldn't ask everyone in the world, we could take a sample and then try to guesstimate that, and using statistical methods to do that. So there's ways that you can take good samples and figure it out mathematically without actually having to ask every single person and make a guess. So suppose we wanted to estimate, or I guess did y'all write that in? No. 2 major techniques for inference: confidence intervals and then hypothesis testing.
The first pocket is fat, the text 2 is back.
What? Never mind.
Confidence intervals.
You don't have to put the units next to them, but you can if you want. Suppose we wanted to estimate the proportion of blue candies, we could say blue M&Ms, in a very large bowl. So imagine that it was the size of this room, and then it just filled the floor, and it was like 3 feet tall. It came up to here.
Know that the odds of prophesying Jesus would be Texas 2 feet deep in quarters?
What?
I don't know. How might we go about estimating this proportion? Shh. What could we do? Figure out how many different colors there are. But what if there's more of the other colors than there are blue?
You get that many out of however.
Gotta go right there.
You just have to count.
You'd have to count all of them?
Yep.
You would go through every blue candy on the floor.
There's no estimating.
Pick
You
like
could.
50 M&Ms and then blue out of the 50 and then...
We could just take a sample, maybe of like 100 of them, then count that proportion. Yeah, you might want to write this down. Not for point estimate. How might we go about that?
How do you know what sample is accurate to the population?
How do we know what?
How do you know if the sample is accurate to the population?
That's a good question. We're going to talk about it.
Oh my god.
I love that question, though. That was a good one.
Hey, if it's randomly selected. Is it Christmas time? Is your Christmas present to me telling me this answer to this
Yes.
question?
Did we get a Christmas present?
Alright, it's time to get on the desk.
It's knowledge.
It's knowledge, you did not just say.
Wait, go back.
So,
Wait, I didn't get to...
Go back to...
so what we would do is we would take a sample and then estimate that. That is called a point estimate. It's a single number or a statistic that is based on the sample to estimate the population.
No. Yeah, I thought that was funny. I saw that. That is what she said. She goes, Dad, love you though. Yeah. You're cute though. I don't like that. I laughed because I could hear being like, yeah.
So let's say that I took a sample of 100 candies and I found that 10 of them are blue. What would my point estimate be? 0.1. That would be, and I would estimate that that is also my population proportion. So the point refers to a single value on the number line. If everyone in here took a different sample, would it be possible that we all got different numbers? Yes, because they could.
It's like the poker chip thing.
It's like the poker chip thing, exactly. It's not always close due to sampling variation, and all that means is that people are taking different samples, so they're getting different results. So different samples may produce different statistics. So not everybody's going to get 10%. You could get one that's 12%, 15%, 5%. Everybody's getting something different.
Not always close to population.
So we're going to do something what we call is a confidence interval. No, this is just hypothetically. So if everyone is guessing at that point estimate what you get in the sample, but would you have more confidence if it were an interval? So we are going to create what we call a confidence interval. So instead of saying that the population proportion is 10%, we're going to say it's between 5 and 15. So then that gives us a little bit more of buffer room to be correct or for it to fall within that point.
Oh, thank God. Yeah, I'm not going to be here on Friday.
That's what our quiz is.
Wait, really?
I don't know, maybe.
I know there is, I know you like.
It's not on that classroom.
I haven't added anything. It's on that calendar, so I'll have to go back and add that in.
This week is not a
So, am I good?
So the primary goal of a confidence interval is to estimate an unknown population characteristic. Lindsay, will you close your laptop for me, please? Thank you. So the whole goal of doing this is to guess the population proportion.
Do we have to write this down?
If you want, you can go back and look at it. I've posted it.
Oh, we posted this on...
Yes.
this whole thing.
So it is the reason why we build this interval is that we're going to have a certain degree of confidence that the actual population proportion will be in that range of values. So we want high confidence. We want to be, there's no way to be 100% confident, but we can be 99% confident. Or we can have lower confidence. So, how confident are you that you can guess Miss Morris's age within 10 years?
2000.
What do you think?
90%.
What do you think her age is between? If you know it, then don't.
50 and 60.
Yeah, she said she was like 50.
I think she's like 50.
Yeah, might be good.
Okay, wait, what do we think?
I would say 52.
But let's think of a 10-year range.
50 and 60.
Between 50 and 45 to 55.
No, I would not put her in the I would say like 50 to 60.
50 to 60.
40 to 50.
She's 50. Wait a minute.
Okay, within 5 years.
55 to 60.
48 to 55.
I'm saying 50 to 55.
54.
Okay, within 1 year.
50.
51.
If you know it, don't answer it.
54. 56. She's not in her 50s.
So what's happening? Shh, listen. What's happening as my interval is getting smaller? So if it's going from,
You know what she is.
yeah, she's 50.
Oh.
So she just had her 50th birthday party this summer, I think. So the point of this, listen, guys, stop talking. It's getting really old. The point of this is that when you have a wider interval, like more gap of ages, you're going to be more confident than if I said guess within 1 year. So the smaller your interval is, the less confident you are. The wider your interval is, the more confidence you have. This is a concept that comes up over and over and over and over. And it's something that can sometimes get confusing and sometimes you get backwards. So what I want you to do is always reference this example because you won't get it wrong if you think about this example. So that's why I always put it on there. Because if you think about guessing an age versus your level of confidence, you're going to be more confident with a larger range of values or a wider interval.
What is her age?
Her age is 50.
She's 50?
Yes. So I'm going to write that down. I want you to say larger interval is higher confidence, and then a smaller interval is lower confidence. You could also use wider and narrower if you wanted. The confidence level is associated with the method used to construct the interval. So it's not like one degree of confidence is going to produce the same interval for everyone. So if I said that I had 95% confidence, and this is on the next page. If I said that I had 95% confidence, then that means that, I'm going to show this picture. Imagine what this picture is 100 confidence intervals right here. And that's what each one of the horizontal lines is. So imagine 100 people at this school went and sampled. We could even use the M&M example. So 100 people came into this room and got a sample of 100 M&Ms. And they each created their own interval based on the number of blues that they had. So everybody's got a different one. And then they put their interval here. And let's say that the actual proportion of blue M&Ms was 12%, so 0.12. And I knew that, but nobody else did in the whole school. So they all did their own confidence interval. The people that actually had 12% in their confidence interval are the blue numbers, or the blue intervals. And then the orange ones are the ones that their interval was not right. Like they didn't have 12% in them. So these were all too low, and then the ones over here were too high. So there's 1, 2, 3, 4, 5, 6, 7 out of 100 that did not catch the actual proportion. But they didn't know they were wrong because they didn't know that it was 12%, but I knew it because I know the population. So how I relate this to the confidence level is out of 100 samples,
It could be
we're 93% confident. And what that means is that 93% confidence means that about 93% of the confidence intervals will capture the true proportion. So 93% of the confidence intervals will capture the population proportion. So in this case, the 12%. And 7% of them will not. So that means if I'm 99% confident, then that means only like 1 out of 100 won't be correct or won't capture the true proportion. The only issue because you probably think like, why would I not always use 99%? When you have a higher confidence level, you have a wider interval. And so that means you're not getting as close into it as you want. So it's going to be a really wide range. Like you can guess Miss Morris's age within 10 years, but is it really helpful to have her age within 10 years, or would you rather have it within 5 years? You just run the risk of it maybe not being as correct. So there are pros and cons to having a high interval or a high degree of confidence. So there are 4 steps. We're going to learn how to answer one of these questions because they are not always, so we're getting into problems that are going to look a little lengthier, and there's 4 steps that you take to answer a confidence interval question. And there are the 4 C's, so it's easy to remember. Conditions, critical value, calculations, conclusion. So you're going to go through these 4 steps when you're answering a confidence interval question. The conditions are the same as the ones from the last unit, which is really nice. This is the proportion side of it, though. So you're checking, is there a random sample?
Yes.
And then you're checking that n times p hat and n times 1 minus p hat. Make sure that you put the hat must be at least 5. And you have to check that mathematically. But you guys were really good at that.
Of course, Miss Thornhill.
So n times p hat and n times 1 minus p hat is greater than or equal to 5. The next thing that we're going to check is the critical value. It's called a Z-star, and that is the number that is associated with your confidence level. So if you're using a 95% confidence level, then it's going to fit a specific Z or critical value. I'm going to show you how to do that in the calculator. And when you do your MyMathLab, it's going to tell you to use a table, but in my opinion, the table is really confusing. So I'm going to show you in the calculator, but if there is some reason why you don't like the calculator and you would rather try the table, then come see me after class and I will show you how to do the table. In my personal experience and opinion, the calculator is easier.
All right, can you show me the table?
So what you will do, I knew you'd say that, is whatever your confidence level is, you're going to type in inverse norm, and then your area is going to be the number that is halfway to 100 from that number. So for example, if I have a 90% confidence level, halfway to 100 is 0.95.
I see you too. And you get 1.6.
And then you use 0 and 1 as your mean and your standard deviation because it's from a standard normal curve. And I'm about to show you a picture that kind of explains why we do that. But that's the process that you would go through. So in my calculator, we already did 90%. So go ahead and type that in. I want you to just check that you can get it. You should get 1.645.
Are they always 0 and 1?
Yes.
I'd like to get a star with it.
Oh no. Hit go to. You need to do 0.95, not 95.
I did.
The reason why we put 95 instead of 90 is because your confidence interval is going to be the middle 90% of your normal curve. So that means that your tail is going to have 5% on each side. So you want to take this z-score right here. That's at the 95th percentile. Okay, if I had a 95% confidence level, what would I put in my calculator?
97.5.
Inverse norm, 0.97501. So just imagine, what is the halfway to 100 point?
Hey, T, did you learn this in your college class?
Yes. You should get 1.96. Okay, 99. What would I put in?
98.
Nope.
I mean, we have 98.
0.99501.
Hey, T, we have 98 on there. That's what I said.
Oh, you have 98? Okay. So then do 98 and then 99. What would you put in for 98? 99.
Oh. I have been right.
But yeah, why does it do that?
Do what?
Like, why is it 0.995?
Because it's halfway to one. Oh, mine doesn't have 98 on it, but yours does. So for the 98, you would put in 0.99. And then for 99, you'd put in 0.995.
If I was just a mom, I'm saying
You did the MC?
do people use this in the real world? Like, what are we looking for?
What are we looking for? We're trying to estimate the population. Proportion. People do
So,
this,
you
yeah.
know, like, how we have 6 billion people on Earth.
In fourth grade? No.
Why is it
I'm
0.995?
not teaching mine. Don't worry.
Oh, because it's halfway to 100.
So you should get 2.576 for 99.
You teach me math and it's good.
No.
Okay, third step. Shh. Listen.
Every day.
Oh no, go back. No.
I have it posted. Calculations. This is the formula to find or to build your confidence interval. And instead of calling it Z critical value, you can call it Z star, but that's just for you to know that it's your critical value. But that's what this is called.
This makes sense.
Oh, I got it down, T. I got it down.
And then these need hats. Very sorry. Hard to build a hat on.
Oh, isn't it just like the standard deviation?
Yes. What? I think I have a hat. I think it just didn't show. It's rough.
Yeah. I'm proud of you.
I do not know. I'm going to check with the dual credit teacher to see if you have to memorize this or not. So for right now, I'm going to say yes. But I'm going to check. Nope. That would be unethical of me.
It's like the
Honestly, they would
But who
never.
cares about
No, I would
that?
never know if you literally gave us.
I know they wouldn't, but that would be inappropriate.
I would do that if I was a teacher.
I think, here's what I think. I think that she's going to say yes, but I'm going to check to make sure. So,
She's nice.
and via email, she's nice.
You ever have like meetings with her?
You never met.
So we call, what I want you to do is circle each part. So the P hat, we call that the point estimate.
I thought that meant something else.
It does. It means what you're estimating the population to be. So whenever we took our sample of M&Ms and we got 10%, that was our sample proportion. That's our point estimate. It's the point in the center.
I'm guessing the Z
So-
star is the Z critical value.
That's your critical value is Z star. And then standard deviation of the statistic. Oh, there's the hats. We call this standard error. So this right here,
Standard error.
what I have circled, that's called standard error. The reason I have you write these down is because if I ever said what's the standard error of the formula or what is the point estimate, you just have to look at it and identify it.
Wait, would there be a problem? It's like find the standard error and you basically just use standard deviation.
Mm-hmm.
Is that for N? What is the Z thing?
Z star, that's your critical value.
What about the N population?
And then the whole thing that is circled is called margin of error. So we've learned 3 things: point estimate, standard error, margin of error. And those are just vocabulary terms.
The Z star and the
So that combined,
that's all.
margin of error. So Z star and the standard deviation combined is called margin of error.
Standard deviation.
So how do you know when a plus or minus? Or do you just
It's both.
Okay.
And this will make more sense once we get to a problem.
Hey, it's
Yes.
It is just population size.
What?
Sorry, N's just sample size.
Sample size. Yes.
No.
Then the last thing is the conclusion. So we will write, we are 95% confident that the true proportion of blue M&Ms is between 10% and 20%. So we're going to fill in the blanks. I just made that up.
But you said memorize, so this is exactly what we have to write. Word
Yes,
for
word for word.
We are
Yeah, write it word for word,
percent
or else you really will get points off. Like,
Write it word for word or you will get points off.
Wait, so when it says context, so we do like a purple dogs
Yes.
is between
Yes.
0%
and you didn't get points off.
I have not thought about this. I have
by CLT,
I
the
haven't looked
I
at
wrote
your grade.
CLT at the end of everything.
I don't know my grade's like 4.
population is given, therefore.
Here's some extra notes, and you'll want to know these because they are questions that typically get asked. So the half width of a confidence interval is called the margin of error. So if I said the confidence interval was between 10% and 20%,
15 is a margin.
0.10 to 0.20, my margin of error would just be half of that range, which would be 0.05.
0.05.
Because it ranges from 10 to 20, right? And we're going to do an example like this. 0.15 is in the middle. Your margin of error is just the distance from your middle to your outside.
To your midpoint to your
Gotcha.
Mm-hmm.
other thing.
Y minus Y1 minus Y2 over
2.
Find the
X1 minus
midpoint.
X2.
As your confidence level increases, the margin of error also increases. Because remember, thinking about
We already wrote that down.
the age. Yeah, you already wrote this down just to check. And the midpoint of the interval remains the sample proportion. So the 0.15 would be my p hat, would be the midpoint. I think you've already written this down, but if you want to write it again, larger sample size. No, you did not write this part down. Larger sample size means a narrower interval. Not sample. We didn't talk about sample size.
What did we talk about?
The like age thing.
Larger, what would that be?
So you will want to write this down. Larger sample size gives you a narrower
What
interval.
was the first one that we wrote down for this? Larger.
Confidence level.
Okay.
Oh, wait, I should know. What was the one that was like confidence intervals? That's still the value.
Population parameter.
Population.
Mm-hmm.
Not at all.
You already know I'm going to be buying.
Because we didn't send her.
They were trash. All of them.
Mine was not trash.
Do you think
I
that
don't even
public
know what I
opinion is better?
Yes.
The allergies.
Where? Imagine being a guy
And they're Solomon.
Evan, what?
Solomon?
She doesn't know if she used that word.
Yes, he does. The other day when he called me humane.
I do not think he used that word right. I don't even know what to say.
Where was it? I'm a humane girl.
Wait!
Does it have to follow both periods?
Yes. Okay, here we go.
Out in the wild.
This is how I would suggest you go through one of these problems, is circling the important numbers. So, in April 1998, they surveyed 883 randomly selected American adults about allergies. According to a report posted, 36% of the sample answered yes to the question, "Are you allergic to anything?" Construct a 95% confidence interval to estimate the population parameter. So we have that 36% out of 883 said that they are allergic to something. But I want to estimate the whole world. So how many people in the world have allergies? I don't know. I cannot figure that out. I have to take a sample, and I'm going to create a confidence interval based on that. So step number 1 is conditions.
Random selected. And given to you.
So conditions, random sample,
So we're good to go.
and I need to check the n times p hat and n times 1 minus p hat. So 883 times 0.36 equals what?
Greater than 5 for sure.
Well, I want to know what that number is.
317.88.
What is it?
317.88.
Greater than 5. And n times 1 minus p hat is 883 times 0.67. And make sure that you're showing all of this work.
Wait, what?
1 minus 36.
You.
Oh,
That's why I take this 6 and 7 does not equal a 0. So just thought I should double check.
thank you.
Ashley. Always looking out for him.
560.
Guys, I really am
Can it ever be equal to 5 or does it have to be always greater?
It can be equal to 5. Greater than or equal. Right?
Ashley's going off. I'm just
Okay,
wondering,
normal
is it from her
distribution.
own
It can equal 5.
mouth?
So that tells me that I have a normal distribution.
I didn't know.
So check.
Well,
Step 2 is what? Critical value.
do we only do it for the 95%?
Yes, so my confidence level is what? 95%. So if I'm doing a 95% confidence level, then to find my critical value, I would say inverse norm of point what?
7.975. I was telling my parents to give me more credit.
0, 1. And you should get Z star equals 1.96.
Yeah, that's what I want. Do you have to say Z star?
I got their team.
So that's what Z. Oh,
Z star is critical value.
Stars are about.
It's an asterisk.
actually, you draw 1, 2, 3.
Okay.
Okay.
Actually, it's stop.
That's the big star.
You have a long, big finger.
I decided that I kind of want a dot of a password. Hey! Just to say I've got. Yeah.
Okay, from here. What's the third step?
Calculation.
Calculations.
That's like
No. Calculations. I'm going to write the formula by itself, which is p hat plus or minus z star square root p hat 1 minus p hat over n. Then
I just plugged it in.
I'm going to plug in what I know. So I know p hat is 0.36.
Plus 1.96.
That's what mine.
0.96. Square root of 0.36 times 0.64 over 883.
this is like a squared plus b squared.
So you're going to do this twice on your calculator. One with a plus and one with a minus.
Oh my.
B plus or minus the square root of
Are you
b
using a
squared.
not error? You're gonna get a
Four
dot.
Yeah,
AC
just a
all
dot.
squared.
So you should put your lower bound first. Your lower bound first, and then your upper bound. If you did that by hand or in the calculator, you'll get these two numbers. I'm going to show you a way that you can run this on the calculator as well. So there's two options. No matter what, you have to show your work. Like showing the formula by itself, the formula plugged in, and the answer. You can check your answer by going to the calculator, and if you have an 84, you're going to hit the stat button. Then you're going to scroll to the right to where you see the word tests. And then you're going to choose option A, which is 1 prop Z interval. If you have an Inspire, then you'll go to menu, stat calculations, or maybe like stat tests, and then it's still 1 prop Z interval. So next to the word calculations, I want you to write 1 prop Z interval, because that is the name of the type of the test that we're doing. Because we have one sample, we're doing proportions, and we're doing an interval. So that's the technical name of the test.
Is the 84 stat test 1 prop Z?
Yes, I think it's option A. So when you click on that, it's going to ask you for an X, an N, and a C level. It's going to ask you for those three things. For the X, that's going to be what 36% of 883 is. So when you type in 0.36 times 883, you get it like 317 point something, right?
Yeah, 317.88 because we used that earlier.
Yeah, 318 or 317 point. Hold on. You get 317.88. The only issue with the calculator, listen, the only issue with the calculator is that it won't let you put a decimal in here, so you have to round to 318.
Oh my.
And then 883 and then 0.95.
Is this for conclusion?
Nope, this is still part of the calculator. I'm just showing you a different way to do it. That's the confidence level.
So we have to like, in order to do the, like a calculator, like how would we write it out to show work?
You still have to write the stuff in orange no matter what.
Okay. So
Yeah.
why do the calc? Oh, just to check.
To check. So this is just to check your answer, and you should get the original answer that you got when you plugged it in. Yes,
The green stuff, is that your final product for all that?
that's just what you're putting in the calculator is the green
Oh,
stuff.
so like, the
It should
answer
give you
for
both.
calculations is 0.328, comma 0.39.
Yes.
Yes.
Alright.
I'll look at it in a minute.
Okay.
Okay, last part is conclusion.
We are 95% confident that the That the true
We
proportion of Americans with allergies is between 32.8% and 39%.
perfect.
That's too much to read. Can I repeat?
We are 95% confident that the
True proportion of Americans with allergies is between 32.8% and 39.2%.
perfect.
You want me to go tell him?
I do what you do.
Yep.
I'll go tell him.
You only pay me.
I'm gonna open it like, could you please
Get after their butts.
See, if I go out there, I'm gonna say something.
Hey! Going out class here!
So next example.
I'm really.
random check.
Nope, just finding the critical
Oh,
value.
we just changed.
Inverse.
What's 88 to 100?
Oh, 88 plus 100 is 188. Divide that by 2.
What about for 80%? What would go in inverse norm?
90.
Good.
No. Is it ever not gonna be a zero?
It didn't say it was a
Mm-mm.
random sample.
This isn't bad.
So do we just?
Yeah, I don't know why you said we
I think you'll still need it.
I think that's what she said in the beginning. I
Ms. Thornhill, do we just always assume that it's going to be a random sample?
I'm going to show you.
Yeah, like on the next one, it's graduating.
It doesn't say random sample. Even though it does not say that, when we get to the conditions part, you're going to assume that it represents the population. So for conditions,
Represent population.
you say we assume sample represents the population. And then we keep going. So if you don't see the word random sample or somehow they randomly selected, you just assume we don't have the data. Okay, I want you to try steps 1 through 4 because the question only says calculate a 95% interval. That doesn't mean you just get the interval and you're done. You have to go through all 4 steps. And also all the amount of space is kind of an indicator that you're going to do all of that too. So steps 1 through 4, I want you to go through them and then we're going to check our answer. I'm going to give you 6 minutes. So make sure you go out 3 decimal places, and then the answers I got was from checking it in the calculator, the stat test A. Okay, let's look at the last example. So suppose you obtain the confidence interval 0.7263 and 0.9352. So I'm just going to put it on a number line. 0.7263, 0.9352. Could ask me 2 questions. Could ask me what the point estimate is, and it could ask me what the margin of error is. Your point estimate is always going to be smack dab in the middle because it's your p-hat. So how could I figure out what the midpoint is of these 2 numbers?
Add them together, divide by 2.
Add them together, divide by 2. Perfect. And divide by 2. You don't have to share your work for this, but you can. And what do you get?
0.8308.
Perfect. So my p-hat is 0.8308. My margin of error is now the distance from my midpoint to the outside.
Oh, so
Either
this is
way,
correct.
you could either take the range and divide it by 2,
I like that.
or you could take your midpoint, your highest point minus your midpoint, and that would also work. So my margin of error 0.9. .1045.
I got 1, 2, 2, 4. Nope, type that out.
That scared me.
My hand.